Okay, welcome back to the video lecture series for Introduction to Geospatial Sciences. What I want you guys, or what we're going to talk today about is how all maps tell white lies. And you may think this is kind of funny. You're like, well, a map can't lie, right? Or maybe we think maps are awesome or that it's easy to map stuff. But there are many reasons why we might say that a map is inaccurate or it's not correct or it tells white lies, right? And that's what we're going to talk a little bit about today. And I know now that we're in this kind of mobile location-based technology era that we kind of demand good data and we expect things like Google Maps to be perfect. Unfortunately, that's just not the case. And so just to get you thinking a little bit about why that is not the case, let's imagine the globe, right? We look at the globe and it is round and it is three-dimensional, right? It's a ball. But who walks around using a globe? Doesn't work, right? The Earth is big, the globe is small, it's impractical. Can't fold it up, put it in our pocket. So what we need to be thinking about is how we go from a ball to a paper map, right? How does this happen? Well, some people get creative and say, hey, just put the paper on the map and trace it. Or maybe we could put a projector up on the wall and trace the outline that we see being projected. Or if you're really crazy, you could whip out a pocket knife and maybe deflate the globe, right? But, let's talk more scientific about it because there are ways in which we do this, and there are reasons for distortions, error, accuracy problems, and the white lies that we see in maps. So to do this, let me share my screen, and we will look at a PowerPoint presentation. Okay. So there's this book out there. It's called How to Lie with Maps. It's probably one of my more favorite books. And in there's a quote. Well, favorite books for academics, right? Not for fun. But the quote is that basically it's not easy to lie with maps. It's actually essential to present a useful and truthful picture. An accurate map must tell white lies. And so what are these white lies we're talking about? Most of which they're inherent to all map products. There are problems with accuracy, or maybe we would talk about error. Maybe the map is not complete. Maybe the scale of the map causes some generalization, or it's not useful. Maybe the way the map was constructed is not logical. Maybe the abstraction methods or how the cartographer went about classifying or categorizing the real world isn't kind of how you would have done it yourself. So the map is maybe confusing. Maybe in real life, the features that we're mapping were highly detailed, but due to data limitations, we had to generalize things. So imagine a curvy road. Well, maybe we can't draw every curve, so we use a series of straight lines to draw the curves. That's called generalization. And maybe there's temporal problems. So maybe the map was made in 1970, but you're trying to use it now. Well, things aren't going to be right. So all of these types of issues or white lies are kind of in all maps to some degree. It might not be a big issue, and this is also not the entire list, but we need to really be aware of this. And ultimately, what makes a good map is whether or not it meets the needs of the user. And so we can kind of not think about some of these things if the map serves its purpose. And so, I really want you guys to think when we're making maps if it is meeting the needs of the users. And that basically implies that all maps specific purpose. You're never going to create a map that is essentially the jack of all trades. You'll have a map maybe for finding routes, or a trail map, or a river guide map. There's going to be a very specific purpose to that particular map, and you can imagine that white lies or problems with maps kind of have varying levels of significance based on the purpose of the map. So if there's a problem with your road atlas, the consequences of that map problem are probably not huge. Maybe you just make a wrong turn. But if you're in agriculture and your maps are inaccurate or wrong, maybe you're making decisions or wrong decisions that result in monetary losses. So it costs dollar bills, right? Or maybe you're in the military and you're trying to figure out where you want to drop a bomb. Well, if your map is wrong and you blow up the Red Cross, which did happen, as a matter of fact, then that's a big deal, right? You're destroying places. Maybe there's lives involved, and so purpose of the map and the results of problems on the map really do vary. So we should be aware of how and when some of these white lies are introduced. So just remember again that even great maps basically have problems. And this is basically a result, as we talked about before, of having to model the real world, which is three-dimensional, in the 2D plane. So we have to put it on a paper map, right, or on a screen. So 3D to 2D. And so again, here we see the globe. Here we see the paper map. How does this happen, right? It's not magic. So basically we use a process called projecting. We project the data. This is a transformation process that basically uses a plane or a piece of paper that we, in concept, wrap around the Earth, either as a cylinder, as a flat piece of paper, or as a cone, and then you can trace geographic features onto that piece of paper, unroll it, and voila, you have a map, right? But each one of these kind of types of projections, right, we can see there are three, have inherent problems. These problems deal with measuring distance, with direction computations, with the shape of a place, and also the area, right? And so here we can see the classic example of Greenland, where if we look at the map, it looks huge, right? It's gigantic. And I always flip-flop Greenland and Iceland, but when we look on the map, right, it looks like it's really big, like it takes up a majority of the northern hemisphere. But in actuality, it's about the size of Africa. And so there's distortions in the area of this continent because of the type of projection that was being used. And again, there's 4 different areas where this can occur. So again, this is kind of a big question. And when I say, hey, what sort of problems occur in maps due to transformation, you should say, oh, I know this. It's direction, it's distance, it's shape, and it's area, right? Just 4. It's always 4. But there are other ways that maps can tell white lies, and so you need to think that any map maker must pick and choose what information to include or exclude from a map, right? It's up to that person making the map. So there's artistic flavor or the artist's choice in map production and creation. And we kind of also need to remember that it's impossible to represent everything in the real world. There's just no way. It's too complex, too dynamic, too much going on, so many different scales. We got ants, microbes, skyscrapers. There's just no way to do it. So again, we have to pick and choose what to put on the map. And so this brings up the ideas of abstraction and generalization. Abstraction, again, is how we think about, categorize, classify real-world objects or geographic phenomenon, also referred to as tuples, right? But then there's also this idea of generalization. So we can't capture all of the detail, so we have to generalize things a little bit, right? We have to take a curved line and make it less curvy by representing that curve with a series of straight lines, right? And we'll go into more detail on this at a later date. But basically, abstraction and generalization introduce more white lies into the map making process. So at the end of the day, remember, not all maps are perfect. As a matter of fact, no map is perfect. And you can see here with these 2 guys wanting to go fishing, lake looked big on the map. They get there, not so big. And these things do happen. So that's all for today. Thanks.